When the graphs of y, which is defined by x squared minus 5x minus 6, and x minus y equals 6, when these graphs are drawn on the same axis, where do they intersect? At which point? Four choices. Here's my x minus y equals 6, the second one. And here is y equals x squared minus 5x minus 6, okay? Now, I don't like having a minus y on this first equation. I don't like having a minus y. I want to solve this for y, but I don't want a minus y. I'm going to do what most people don't do. I'm going to add y to both sides. I'm going to add it here and here. So you end up with x equals y plus 6. Now I'm trying to solve this for y, so next thing I'm going to do is subtract 6. Take away the 6 from here and from here. Draw a line and subtract 6 so that x minus 6 equals y. So we've solved this equation for y, and we already know y equals this over here. So this equals x squared minus 5x minus 6. So y is the same in both of these equations now. So if I copy this up here, I don't have to write the y. Okay? So x minus 6 equals y, which equals x squared minus 5x minus 6. Now, I would like to have a 0 on this side over here of this equation. So I'm going to get rid of the x. On both sides, I'm going to subtract x here and here, draw a line. And since I want to have 0, I've got to 0 out the negative 6. So I'm going to put a plus 6 here and here. Okay? We're getting 0 for the left side. This equals x squared. Minus 5x and minus 1x is minus 6x. And these two cancel out, so I don't have to write them. So now I have x squared minus 6x equals 0. I can factor this over here, take an x out of both of these. 0 equals x times, factor an x out of here, that leaves you an x. Take the x out of this, leaves you minus 6. So x times x minus 6 equals x squared minus 6x. We're factoring the common monomial x out. Now, either x equals 0 here, we can write this over here and copy this on the left side, copy this on the right side, but x equals 0, or x minus 6 equals 0. Okay? Now, if x minus 6 equals 0, we can add 6 to this side and to this side, and you're going to end up with 0 over here. You're going to have x equals 6. So here are my two answers for x. Okay? Copy that up here. Now remember, we had all this up here a minute ago where y equals both of these things. Well, I just want to remember just this part of it right here. Okay? Define this for y. We had my two answers for x. Write this up here. Let's put the y on the left side. Y equals x minus 6. Let's write that. Y equals x minus 6. Now, we're going to write y equals x minus 6, or y is x minus 6, and we're going to put 0 in for this one. Put a 0 right here, okay, or put in a 6 in there for the x. See x equals 6? Substitute for, let's say y equals, in place of x, put 6 minus 6. In this case, y equals minus 6, or in this case, y is 0. So now we have our 2 points of intersection. The point is 0 here. When x is 0, y is minus 6. Or when x is 6, y is what? 0. So for my four answers, I'm going to pick this one. Okay, and that answers this question. Now, we're talking about graphs, and I'd like to show you that these points, that these functions do intersect at this point. In fact, we're going to show you where they intersect at both of these points. Only one of these was in our answers here, and I picked this one for D. But just for a minute, let's start to graph these things. Okay, we finished our question. If you want to stop there, that's fine. But you know I like tearing things completely apart. We're going to graph this function, and then we're going to graph this function, and then I'm going to show where they intersect on graphs, okay? Where the graphs intersect. Now x is 0. That's x squared minus 5x minus 6. Put a 0 here. That zeroes that out. Put a 0 in here. That zeroes that out. And we're left with what? Okay, so there's 1 point. Okay, put a 1 in there. In place of 0, Here, put a 1. In place of x, we're going to put a 1. Put 1 here and here. That's 1. Let's see, this is 1. And negative 5 times 1 is negative 5. Okay, so this is 1 minus 5 is minus 4, and minus 6 is minus 10. Now we'll plug in a 2 in here. 2 squared is 4. 5 times 2 is 10. 4 minus 10. 4 minus 10 is negative 6, and negative 6, plug in your 2 here to get 10, is going to be negative 12. Okay, plug in a 3. We're going to get 9 for this, aren't we? And 5 times 3 is 15. 9 minus 15 is a negative 6, and negative 6 is negative 12. Now there should be a point in between these two. Since we're repeating here, there should be a point somewhere in between these two. So just for a second, put in 2.5. Square 2.5, that's 6.25. This is 5 times 2.5, that's about 12.5. And when you do this, you're going to get 6.25 minus 12.25 or 12.5, something like that. You're going to get a final answer a little bit less than 12 here. You're getting 6 minus 12 and minus 6. So you're getting the negative 12 here. A little bit more than negative 12. Okay. Now you would expect, since you had 10 and 12 and 12, and then you get your vertex here, you would expect the next point here to be a negative 10, wouldn't you? Let's see if it is. We're going to plug in what? 1, 2, 3, 4. 4 squared is 16 minus 20. 16 minus 20 is negative 4, negative 6. Yep, that's what we figured. So the next point you should get what? When you plug in a 5, I should end up with a negative 6 here. Anyway, there's 25 for these two. 25 for these two. They cancel. Minus 6, just like I said. And then when you plug in 6 here, you're going to get 36. Minus 30 is 6. Minus 6 is 0. So here we go. We're going to graph this now. I quickly just copy down my x's and my f of x's, or my y's. Okay. Just copy this column down and this column down over here. I don't have to have all this anymore. Well, let's write my my function up here and copy that down one more time. Then we'll start graphing these points. 0 minus 6. 0 down here at 6. 1 to the right and down 10. 1 to the right, 6, 7, 8, 9, 10. 2 to the right, negative 12. 2, 10, 11, 12. Here's your other 12 over here. Remember your second 12? In between those, we get something just a little bit less than 12. Right? Smaller than 12. Down here, we say smaller than. I mean, numbers that are farther down here are less than numbers that are up here. Anyway, we're going a little bit to this side of the 12. And you see this point right here? We're going to come over here, draw another one. Those are my 10s, my 4, 10. Count it. 1, 2, 3, 4, and you go down 10. Then you're right here. Then here's your 6, 0. Come over here and put another point. Here is your parabola. So now we've graphed this. That's the hard one to graph, all right? Now, when y is 0, and this is a function right here, when y is 0, we have x minus 0 equals 6. X is 6. Okay, so that's one of my points of intersection. Now, when x is 0, minus y is 6, so y then is minus 6. You understand what we're saying? Plug a 0 in here. He's gone. Minus y equals 6. So y has to be a minus 6, which is down here. Okay? Draw my line through these points. We need some more points through there as we draw the line. Okay? Where do they intersect at? 6, 0, this point. Another point where they intersect is 0 minus 6. So we're going to say D. Okay? And that shows you what we're talking about, the graphs intersecting. We worked it a long time ago and got the answer, but I just thought you ought to get a feel for this, a real feel for this. Okay?